In the famous words of Rebecca Black, it's Friday, Friday, Friday. And she was obviously talking about Fusion Friday with none other than Fusion Phil here at JIT Cam. This week, we're going to talk about one of the most common things I think I get asked about on a lathe. Number two being dual turret, of course. But number one, bar pull and Partoff, right? You're running production or you're running a smaller batch and you want to automate the entire system. Well, I'm going to show you how. However, I am going to warn most of you that most post processors may not support this. However, you guys all know myself over here at JIT Cam. Reach out to me with my email down below, and I'm more than happy to see what I can do about getting you guys set up. Now, before I go into this, I do have to give you guys the old griefing of the likes, the comments, and the subscription. I get a ton of people that tell me my content is great. However, they don't comment down below to let me know that. They do it in the like field, which we highly appreciate. So don't forget to do that. And by the way, you can leave a comment on content you're hoping to see. So let's jump into this. So very first thing is of course, I have my setup created. At this point, I think a lot of you may be a much more advanced user of Fusion. However, for those of you that are beginners, I am going to go ahead and create some tool paths on my part for context. Again, you can use templates. We did a video on templates. I'm probably going to pop that up right here if you guys want to go check that out. But when it comes to your HAAS machines, this is already in a HAAS post. What you're going to want to do is 4 steps, right? That first step is going to be a sub-spindle grab. Now, if you're new to sub-spindles, what I'm doing here is I'm setting the location of how far in I want to grab onto that part. Again, that allows me to grab my part, and then we're going to sit there and wait for our next operation, right? So because we are doing a bar pull, we're actually going to stop the spindles altogether. From here, we're going to go ahead and do our very first thing, which is going to be a pull motion. So I am using spindle return, right? Sub-spindle return. Again, we can have this stopped. We are going to unclamp our primary. And now the feed plane that we want to move to, this is where we're actually pulling. And this is how we're going to set this. So this is a neat trick that I have found out is we're going to use an expression because you're going to turn this into a template later and you're going to just rinse and repeat this, right? So we're going to work from the actual stock Z high, and we are going to subtract the surface. If I could type this morning, surface Z low, right? So what that is now going to do is that's going to pull stock front to basically model back, right? Z low surface is the lowest point in Z axis based on the surface of our model. Now, that being said, is we do need to also account for our tool change, right? So what I'm going to go ahead and do is we're going to go in here and we are going to say, we're going to subtract our actual groove width if we know it. Now, I don't know my groove width off the top of my head, but when I go to build out my tool, I am going to use a 156 groove tool, right? So again, is you can add in these parameters, and you do have to add inch to this if you're using the Freedom units. Oh, go ahead and back up. And as you're going to see, I'm also going to throw brackets around this first section. So what's happening here is we are now getting our 2.5, and we're actually going to add a plus there. I apologize. Even the best of us make mistakes, right? So what I'm looking for is that 2.5 plus the width of my grooving tool, right? So that being said, we have now calculated the total distance that we want to pull out our part for our next operation, right? And for you out there asking, I did a 1/4 inch piece of stock in the front of my part, and then I did go through and I actually set this up to be in addition to the actual length of my part of 2.25. So as you can see, we are now pulling that material all the way out here to account for the distance of stock in the front, plus the length of my part, plus the width of the tool I intend to use. So from here, we're going to go ahead and we are now going to do our part-off cycle. Now, we're going in, and this is where I think a lot of people confuse this part of this, is we're actually going to part off at machine home, more or less, right? So whether or not you go origin, which origin will work fine, or if I like to do is stock front, we again need to do an offset, right? And that offset is going to be based off the groove width of our tool. So as you're seeing now, it's going to bump it forward, whatever that distance is. We haven't selected a tool yet, which I should have did out the start. Even the best of us make mistakes, right? But as you're seeing, we're now bumping that tool forward 156 as we defined on everything else. Now, again, my tool is a little more precise. I think this is a millimeter tool versus using an inch tool. So the translation coming through here, I could copy and paste this back into what we did with that other expression, right? So again, we have now came in and we're going to do our part off cycle. But what I do want to do is I want to show you guys that you may want to actually set your offset for your clearance much greater than what you're expecting, right? And the reason for that is you want to actually wrap it down, do your part, and then come back out. And we could stack these together, which is kind of nice. So I'm actually going to say this guy is off my outer radius. And then this guy could actually be triggered from my retract radius. So again, as these are stacked up together, and as you're seeing, as we now wrap it in yellow, then we do our blue cutting cycle. Again, I did nothing more than reference each one of these to the lower level. One other thing that I may want to do is actually set my approach and retracts to the first and last tool point position, just because that means we're out here bigger than our chuck that's grabbed on. You know, our chuck came in, it grabbed, it pulled out. Now we're wrapping outside of that and then coming down into our part. So again, there's 4 steps, right? We grabbed, we pulled, we now parted off. The last thing we need to do is we need to do our return, right? So what I'm going to do is I'm going to go in, we're going to do another return, and this return is going to keep both clamped, and I'm going to put this back to my sub-spindle machining position, right? So as we've done that, again, we've came in, we've clamped onto our part, we've then pulled our part out, said distance, and we used an expression based on stock front to model back. And then in addition to, we added a tool width. Then we've parted off at 0 because remember, our part is pulled out now, giving us a nice clean face at 0 to go into machining our next part. And then lastly, we've actually taken our sub-spindle all the way back to its machining position. So when we post this out, and again, I'm going to use the HAAS post. We're going to make sure that we have the live tooling turned on. And again, either positional or contouring, depending on your machine. And what you're going to see here is we are going to get some code. So as you're seeing here, we have our sub-spindle grab, right? And then we're doing a sub-spindle return, which I failed to clamp the primary spindle. I knew I was going to do this. But then we are getting that B distance of motion, which you saw show up in my window. So let's go back and make those couple of changes real quick. So again, I'm going to go into where we do our sub-spindle return. We want to keep both clamped. Again, that 256 as you guys saw it. Once again, we repost out this entire area. And just like that, we now have our ability to unclamp primary and then clamp the primary back down. So again, as we grabbed on, we unclamped, we pulled back, we reclamped, and then we went in and we parted off at Z0. Again, I'm at X 10.5 as my first point, clearing of course, my sub-spindle that's holding on to my part. And then again, we send everything back to B0 on that sub-spindle. Now, with that, I do have to say, this is something that if I was doing this all day, every day, I would for sure store this as a template. And this would just be my bar, pull, and part off. So that in the future, because of the way we've set all this stuff, the only real variable you have to worry about at the moment is just making sure in this actual distance that your expression reflects the exact width of the tool that you're using to part off, right? And that's the only thing that you have to really worry about, that you've automated this down to being a copy and paste and inserting from a template, right? But now let's look at a little different scenario here. Again, this works great for HAAS. However, this isn't going to work so well for a Tsugami or a Fanuc control. So for those machines, what you're going to actually have to do is we're going to go ahead and junk all of this real quick because it's easier to start fresh. And now what I'm going to do is I'm going to come in and I'm going to do, again, my sub-spindle grab, right? We are then going to do a part off. And again, I'm going to go ahead and grab my part off tool. And what you're going to see here is we're now parting off the backside of our part. And then I am going to do, of course, my sub spindle return, and we're going to keep both clamped, and we're going to go back to a machine position. However, upon posting this, not only do I need to change my post processor, but I need to show you a special field inside this post processor, which is called pull at cutoff, right? So what this is this is a manual NC action that is based on the inside of the post that is going to control of this, right? So we went ahead and copied that. I'm going to go back again. And what we're going to do is we're going to do our manual NC. Again, we're going to add in our action, right? And then I'm going to paste in that pull at cutoff. Now, what it's going to want me to do is it is going to want me to put that right after the spindle grab and right before the actual part-off operation. Now, keep in mind, guys, first point, last point again applies. Be careful when you do this for the first couple of times. But this time when I post out, what we're going to see is, one, I have to go back to that Tsugami post. And two, we are going to get, again, a bar pull motion based on just that manual action in there, right? So again, this is very handy because this guy here will actually go in and auto calculate those bar pulls as well for you based on what is going on. Now, if you guys are getting a bunch of weird things, and I see this all the time, that people are just fudging numbers in here and messing with stuff versus Fusion spitting out the right stuff, it really leads me down the path of, one, concluding what you guys have seen here today to do a bar pull and part off is possible in Fusion 360, but it also leads me to, it's not what you know, it's who you know. And you all know myself over here at JIT CAD CAM. We are more than happy to work with you on adding this to your post processor or finding a workflow that works best for each and every one of you when it comes down to your machine and your use case. But as always, guys, I do got to say it. I hope you have a great rest of your weekend. I mean, it is Friday and it's probably 5 o'clock somewhere for some of you watching this video, but go out there, get the day done.